Hi everybody, this is Kevin and welcome to my tutorial for exercise 1 in Zelle chapter 8. And I want to point out here that this is not the programming exercise from the textbook. This is an alternative one that I've cooked up. And the skill that we're trying to learn here is we want to be able to process a series of inputs, in this case integers, that are entered at the console using the Sentinel value pattern that we learned in chapter 8. And also using a while loop that we are able to exit with the break statement. Okay? And in particular, we want to make sure that the program works even when there are no values input. And that's because the examples from the Zelle book are not that robust. If you don't put in any data at all in the examples from the Zelle book, you are going to blow up on a division by 0 in most cases. So let's get started. We're going to define a main. Okay. And it's going to take a colon. And just to satisfy the editor, I'm going to put in pass there to keep that from being empty. And then down here, I'm going to have my call to main. And everything's fine. So the first thing I want to do is I want to print out a polite message that says what our program does. So I'm going to print, and I'm going to say process a series of integers entered at the console. Okay, that's descriptive enough. And I want to have an extra blank line that comes immediately after that, and I can have a lone a print statement here to get that, but I can also use the \n to get a new line. So I'm going to do it that way. Okay, and what am I doing while what kind of processing am I doing? Well, let's see. I am processing a bunch of integers that are coming in at the console, and I want to count the ones that are evenly divisible by 5, count the ones that are less than 0, count the negatives, and count the ones that are greater than 100. So I'm going to have some kind of counters ready to count those values. So I'm going to declare and initialize. Well, we're not really declaring. That's old world talk from other languages. But I'm going to define and initialize 3 variables. I'm going to call the first one count. I'm going to make that 0. Well, you know what? I'm going to do this a fancier way. Okay, the overall count I'll get by adding up all the individual counts. So we have we need a count of the numbers divisible by 5. Okay, evenly divisible by 5, but that's close enough for a variable name. Count, I guess we want negative. Okay, and again, when we start, we don't have any of those. We've got 0. Okay, and then the other ones are greater than 100. Count over 100. Okay, so that's over 100, not over 99. All right, so we've got that. Now, pretty typically when we're doing this kind of work, we want to have some kind of loop. Okay, and this is an indefinite loop because we don't know when we're going to get the signal to stop. In our case, the signal to stop is going to be just a plain old press enter. Okay, why is that? Well, that allows us to have, we don't have to pick a sentinel value that's a valid value for the counting application. In fact, we're just going to pick one easy one, which is an easy way to signal that we're done. Okay, so looks like we're going to need some kind of a loop. Okay, and what I want to use in this particular exercise is I want to use a loop that's going to do the reading and the processing, and we're going to get out of it simply by using the break statement. Now, break is a kind of controversial statement, not one that I really favor. And what it does is wherever you are within the loop, if you encounter the statement break, you break out of the loop and you go to the statement after the loop. Now, it turns out that that's a kind of a sensational and abrupt way to leave a loop. Okay? Some people think that it's okay. Other people think that probably it's not. I'm probably from the second group, but I'm going to show you how they do it this way. And then, of course, in the next one, we're going to do it a slightly different way. Okay? So here, we're going to have a while. Okay? And it's going to go until we jump out of it. So we need some expression that's going to keep it going forever. And the programmer's trick is to say while true, okay, which will go forever. Okay, well, how do you get out of the loop? Well, break actively jumps out. Okay, so up in the top we're saying run the loop forever, and then inside we say no, we're taking a quick exit. Okay, so while true. Okay, so what are we going to do? Well, the first thing that we're going to do here, we could have done this in a couple of ways. We could have had a priming read before the loop, okay? And then we could have our other read at the bottom of the loop, at the bottom of the body, okay? And we've done that, and that will work, okay? But I want to show you another approach that they show in the textbook, and we're going to get some experience with that approach too. And that's where you set up the loop such that it does the read at the top, okay, and then it does the processing after the read. So let's do this. Let's say a value as string, because that's how we're going to get it in, okay, equals input, and then we're going to have our prompt. So let's say please enter an integer, press, and then we're going to put these little greater than or less than signs, enter to stop. Okay, and we'll put an extra one out there. So they'll get the idea. Just a plain old enter will stop it. Okay, so then we're going to do our processing, right? So we're going to turn the string into an int and all that kind of stuff. Well, we're getting ahead of ourselves here because maybe we just got an end of file. So maybe we don't have a value to process. How do you deal with that? Well, typically, anytime you read and then you're about to process, you need to check for end of file. So how do we check that? Well, it turns out that in these kinds of files, these text files, value as string is going to come back as the empty string. So equal empty string. Okay, that's how we know we are at the end of the file. Okay. And what are we going to do? Well, we're going to do this magical exit. Again, this isn't really particularly my style, but a lot of people like it, and that's why we're learning it here. So we're just going to say break. Oh, sorry. Just a little Java comma, semicolon got in there. Woo! That little finger, it has a mind of its own. It's typed close to 20 years of those commas, so it always wants to go in the end. Okay, so if it's end of file, we're out of here, right? We are absolutely out of here. Okay, let's just assume that that's the end of it. Okay, well, that's not going to be good. Let's see what happens if not. Okay. Do we need to code an else? Actually, we don't need to code an else. I'll tell you why. Just as a plain old if, okay? If this turns out to be true, it's gone. It's out. We never get to the else, okay? So we don't have to have the rest of the logic hanging off of some kind of else, because the only time that we get there is when we had a real value. We got a real value back. Oh, we got a real value back. Well, don't we want to turn it into an int? Because these are supposed to be ints. Oh, sure. So let's get a variable value equals, and let's use int to process value as string. And you may say, well, Kevin, I could have used eval, okay? And one of the things that we're going to be discussing in the course really starting this week is that even though eval is a really useful method or function, it's also somewhat insecure, because what eval does is it really uses the Python interpreter to evaluate whatever's in the string as though you typed it into the interpreter. Okay, well that's great, because if you type in an int, it'll send back an int value. It'll create the proper int object. If you type in a float, it'll create a float object. That's really good. The problem is that you can type any old Python command you want into that string, and the Python interpreter will try to do what you say. So that allows bad people to give you input that's trying to hijack your application program. So for the most part, from here on in, we're going to decide if it's appropriate to convert it to an int or convert it to a float, and we're going to use int or float instead of eval. Okay? So that's what we did there. That was our first time with that. And then now I need to do my processing. Okay. So let's do this kind of thing. Let's say if, okay, value, let's get the remainder if we divide by 5 equals 0. Okay, if that's true, well then we want to bump up that counter. So count divisible by 5. And a good way to bump up a counter is to say plus equal 1. Okay, that's good stuff. All right. What do we want now? Do we want an else? Do we want an else if? Well, because we have already because we have already done the one value, if it turns out that it's divisible by 5, it may also qualify as some of these other things. It may be divisible by 5, and it may be negative, and it may be, well, it wouldn't be over 100 if it were negative. but more than one can be true. So what we're going to do is we're going to test these all individually, okay? Because I think that's a good design. So let's say if value less than 0, right? Then we want to say count negative plus equal 1, right? And then the last thing we want to do is say if value greater than 100, well, we want to do the same thing, count over 100 plus equals 0. All right, so we've done our counting, okay. And we're at the bottom of the loop in the other approach, the one where we do a priming read before we get to the loop. And what we typically do is we do our processing and then we do the read at the bottom. This one, where we're putting the read at the top of the loop, we do have to check for end of file. Okay, so we don't have that problem. We have that problem, but we do our processing and we just that's the bottom of the loop, because when we come back to the top, we're going to be able we're going to do another read at the top of the loop. Okay, looks good. All right, so then here's the loop. We're going to go round and round and round, processing all these things until we break. When we break, we're going to come down after the loop, which is right here. Okay, and do we want to just print the counts? Well, we could, and we'll have no division by 0 problem. Okay, because the examples in the book are averages. So when they divide by the number of inputs, they get division by 0 if you don't enter anything. But it's typically good to check and see if you got any inputs at all. If you don't have any inputs, you might want to say that in a polite way. So let's get used to doing that now. So let's say if, and let's have an expression. Oh, I'm sorry. These things are not exclusive with each other, are they? No, they're not. So we may have some that don't qualify for any of these. Oh, so we had better be counting. So we better have a count, just a plain old count. Let's do that. Okay, so count equals 0. Okay, and then geez, we have to remember to we're going to have to do that somewhere. Let's bump the count up as soon as we know that we have a valid int. So let's say count plus equal 1. Okay, so now we're doing that. So now down here, when we're ready to, when we're done with the processing, we can say if count equals 0. Well, there we're going to print something nice. Print no values were entered. Okay? Say something like that. Else, we did get some values. And then let's print some appropriate things. Let's print one line for each of these. So print number evenly divisible by 5, and so that we've got that, and then let's say, let's put out the count. Oh, sorry, don't want that inside, I want that on the outside, right? count, divisible by 5. And let's say print let's be a little more descriptive. Count of values evenly divisible by 5. And then we'll say the same thing. Count of negative values. And we'll do count negative. Okay. And then we'll do the last one. We'll say print a third one. And we'll say count of values greater than 100. Okay, and we'll do count over 100. Okay, so that's about it. So the major feature of our program so far is this while loop. It uses this while true trick such that it just will keep going around until we actively jump out. And it uses the break, which some people like and some people don't, in order to get out. Okay? Well, let's see how this works. Let's give it a test. All right, so we give it a run. So process a series of integers entered at the console. Enter an integer, press enter to stop. You know what? I'm just going to stop right away. No values were entered. Wow, I kind of like that. Yeah, that looks good. I like that a lot. I would have liked it if there were a line before that. So let's do this. Let's put a new line before that, \n. Okay, good. Let's run it again. No values entered. I like that better. It's not all jammed up against the prompt. Okay, so we've been able to show that it's robust enough to detect no data. Okay, let's put some data in. Let's do a little more testing. Okay, so let's see. Let's put in 1, 2, 3, 4, and 5. Okay, and just hit enter. So count of values evenly divisible by 5, 1. Count of negative values, 0. Count of values greater than 100, 0. Well, I don't like them all crowded up there. So you know what? I'm going to take the first one and put a \n in front of it so that we get an extra blank line. And then let's run it again. Okay. So I'm going to run it again, and I'm just going to give it the same values again. 1, 2, 3, 4, 5, enter. So, the same answers, but a little prettier for me. Well, I like that. Okay, so now we need to know whether it can count negative values. And make sure that it's not having a problem of thinking that things are negative when they're zeros if we're not off by 1. So I want to put in a 0 and make sure it doesn't get counted as a negative. Okay, so let's run it again. Okay. So the first one I'm going to put in is going to be 0. And then I'm going to put in 1, 2, 3. Okay. None of those should be counted as any of our qualifying things. And then let's take a -1. Okay. And let's just see how that goes. So count of values evenly divisible by 5. It's saying 1. That's looking wrong, doesn't it? Okay, so we've got 0, 1, 2, 3, negative 1, and I don't know which one came out as evenly divisible by 5, but that's a bad answer. Let's see if it's the negative number. Let's see how that goes. Let's try it. Try it again. Negative 1. Nope. 0 is evenly divisible by 5. Sure it is. It goes in exactly 0 times. So it's my 0. What a silly guy. I wasn't thinking of that. So here, if I just put in 0, I'm going to get one of those. Okay, so now I'm doing better. Now that I understand my number system better, I'm doing just fine. Okay, let's try another one. Well, let's try 0, negative 1, 2, 3, negative 5, negative 100, no, negative 101, okay, and let's see what we get there. So it even though it was greater than 100 in absolute value, it didn't count, so that was good. That's what I wanted. Count of negative values, negative 1, negative 5, negative 101, that's good. And evenly divisible by 5, well, negative 5 and 0. Okay, I think that's working pretty well. And again, I just want to show us again that it handles the situation where we don't pass it any input at all. So we just go right to stop. That's it. Okay. Now that's the kind of thing you want from robust coding. Okay, and how could we handle that? Well, we made sure that even if we got an end of data on read 1, okay, that we didn't try to process it. Okay, we're only processing, and why are we not processing it? Well, because we jumped out with the break. Okay, now did we do it in a classy way? No, we didn't do it in a classy way, and I'm going to show you when we get to the next one how to do it in what I consider to be a classier way, and we'll see how you think about it. Okay, so that's it for the tutorial for exercise 1. I'll be back soon with the next one. Until then, oh, you know what? I didn't test this to make sure that I passed the code inspector. So let's put the old code inspector in for the current file. And let's see, we've got 1 week warning. Remove redundant parentheses. Oh, yeah, oh, while true. I like that. So while true, in other languages we have parens around the true, and we not here. Okay, so that saved me some Python embarrassment. Isn't this code inspector nice? And we're going to run this, and we're now telling me that 2 typos. Sentinel is misspelled, because that's Sentinel. That doesn't look right either. Let's see the other one. And the other one is integers. It should have been integers. Now, where's that? Process a series of integers. Okay. So we're going to try it one more time. And spec code. Give it a run. I'll be right back. I bet you didn't know that I Sentinel. Yes. All right. Bet you didn't know that I couldn't spell Sentinel. Well, now you know. Words out. And we run this. And we got the little thing. No problems here. So what I really like of all those, misspellings are not good to leave behind. But this, while true, well, it was kind of working, but it was not real Python-like. And it turns out that the Python crowd says that something is Pythonic or not. If something is in the true style and spirit of Python, they'll say it's very Pythonic. So they would have said, well, that while is legal, but it's not Pythonic. So we cleaned it up. Now it's legal and Pythonic. Okay, we're all done here. See you next time.